Yes guys, so we are doing 11 question. Question 11, as I have just told you, that find the position and nature of the double points on the curve this, which I have written down here, distinguishing between the cases a greater than 0, a greater than b, or a less than b, or a equal to b is not given here, but we will take a equal to b also. Okay. So when conditions a greater than b, what is the position of the double point on the given curve? That curve I have already taken this. So that solution we have to find out. So differentiating first partially, as I always say, partially with respect to x and y, respectively. Okay, so respectively we have to differentiate it partially with respect to x and y. If I differentiate it with respect to x, that means del f, del y, del x, is equal to this one. This is the only term which is in x, so it will give us twice x into y square. This is first equation. The second let me take, and del f, del y will give us, all the terms are by terms, so it is twice x square y, first one. Now it is to be differentiated by product rule. So let's take minus sign is twice a plus y. We have first differentiated first term into b square minus y square as it is. Now this is to be differentiated. This is minus twice y, differentiation will be of this. This is 2 multiplied to this is 0, minus plus 2, this is plus twice y into a plus y whole square as it is. Only this minus y square we have differentiated, then minus twice y, but minus sign was already there, with plus sign. Okay. This is your third equation. Equation number 3 here. Okay, now double derivative, let me find out. If I find out, no need of double derivative, let me first check that what is the equation here. Okay, first just to find out coordinates of these points, let me first find out the coordinates. Then if needed, we will require, okay, from the tangent we will decide, because let me take the tangents of this equation. If we are able to find out what are the points here of the double points, coordinates of double points, and because we have to check the tangents position at A, B, and C, so I'm not finding out second derivative. Okay, so second derivative is not required at the moment, because we will prove that when A equal to B, or A greater than B, or A less than B, what are the conditions for that? Okay, so tangents situation will be defined. So let me take them one. Now let me, for finding the double points, equating del f, del x, and del f, del y to 0. So we get, what do we get here? So we get del f, del x is 0. So del f, del x equal to 0, imply that x, y, or x, y square equal to 0. So from this we get x equal to 0, y equal to 0. This is the point here. And del f, del y equal to 0, imply that this one. Here, if I substitute x equal to 0 in this equation, these two terms will be 0. Putting del f, del y equal to 0, and x equal to 0, putting in third equation, putting in third, so we get, what do we get here? There is your y we have to find out from this one. Here, this equation will be there, and this is 0, because when x is 0, this equation is 0. This is obtained. That means if I take a plus y common, let me take a plus y common, we will get twice y within bracket a plus y minus sign, so twice into b square minus y square, because a plus y are taken common, twice a plus y, so b square minus, and 2 also we can take common, let me take 2 common, this twice is also common, okay, equal to 0. This is from del f del y equal to 0 and x equal to 0. So x equal to 0, if I substitute here, this term is 0. From these two terms, we have taken common twice into a plus y is common. Twice a plus y common. So from this, y is y into a plus y left over, minus this is b square minus y square is left over. Twice a plus y we have taken common. So what is left to us? This is from this we get y, this first term. Let me first further solve it. Twice a plus y. Then in bracket this is a y plus y square minus sign. This is b square plus y square equal to 0. Now this is a quadratic equation type. From this we get a or y equal to, let me take, from this y equal to minus a from first equation. Okay, and from this part, what do we get? This is twice y and twice y square plus a y minus b square. This equal to 0. This is the quadratic equation here. What is y quadratic equation? Because we have here y square twice y square plus a y minus b square. So from this, the value of y will be two values. Okay, by that method we have to find out. Let me solve for this. So what do we get here? Let me solve it here. The first y is equal to minus this we have obtained. The second is twice y square plus a y minus b square equal to 0. From this y equal to minus a, this minus a plus minus under root a square minus 4a into 6, so this is plus 4 to the 8. This is 8 into b square. Okay, so from these, y are the two positive values. Values of y are 2 from this, and y minus 1 is there. So how many points are there? X equal to 0, y equal to 0 we have obtained. What are the points here? So different points are there. So let me check that which point is going to prove that. So that point will be, so first point is 0, x is 0, and y is minus a. Let me take x equal to 0, y equal to 0, x equal to, y equal to minus a, 0 and minus a, point a. Because from first one we were having y equal to 0, x equal to 0 also. And second y equal to minus a. And this point y equal to minus a upon 2a also here, upon 4 here, 1.2a means 4. There are 2 points, so this is 1.4 plus 1.4. There are two values here, minus a plus minus and 2 a square plus a to b square. These two values are there. What are the points? The first point is 0 and minus a. Let me take. Then 0, 0, 0, 0 also. Then 1.4 and these 4 points are there. So different points are there. X is 0 and there are 2 value is 1.4. First is minus a plus under root a square plus 8b square. 1 point and other is 0 and 1.4 minus a. Let me take greater sign. Okay, minus a minus sign and a square plus 8b square. So these points are there. Okay, so all these there are number of points. Now let me check whether which point give the curves satisfied. So let me find out these are possible double points. Okay, so the double points, these are possible double points. The double point which will satisfy the given equation may be the possible double point. Let me check that possible double point. Okay, so what is the possible double point here? If I put here 0 minus a, this is 0 term. Okay, because 11th question says this 0, the x is 0 here, y whatever, and from right hand side y is equal to minus a. This is y equal to minus a, but this is also 0. And y equal to minus a will give right hand side 0. So adding 0 and minus a, 0 equal to 0. The equation is satisfied. Equation of the curve is satisfied. And at 0, 0, if I say, the left hand side is 0, but right hand side will not give us 0. So 0, 0 is not satisfied. And other points are also not satisfying. Only 0 minus a is the possible double point. Okay. So 0 and minus a is the only possible double point. Is the only double point. Now 0 minus a is the double point, possible double point here. Now shifting the origin to 0 minus a. Okay, from there we will find out the tangents. Then we will check the shifting the origin to 0 minus a. Let me do that. 0 minus a is the only possible tangents. Now let me check that what is the position of the tangents here then. So shifting the origin to 0 minus the new double point or the double point. Origin to 0 minus a double point. So whatever the double point we obtain, we shift the origin 0, 0 to that point, the double point. So from the origin, this equation, what do we get here? So in this equation, if I substitute, this is the equation, we will get x square as it is. But in place of y, we will put y minus a. This is into y minus a whole square, because y square is there. This is equal to, from this, if I put y minus a, it is only y, a cancelled out. It will be y square. Second part is b square. Let me take a small the middle bracket here. So b square minus, this is y minus a whole square. Try to understand what we have done. We have shifted the shifting the origin to the double point 0 minus a. So what we do? X plus 0, y minus a. We substitute in place of y as y minus a. At place of x as x plus 0, so there is no difference in x. X will remain same, but y will be changed as y minus a. So we have placed y minus a in place of y in this given equation of the curve. So new equation is obtained like this. Now if I solve it, let me further solve it. It will give us x square. If I open this, this is y square minus y a y plus a square equal to y square. If I open this also, this is b square minus y square minus a square plus y is ay. Okay, so let me open this whole equation. It will give us x square y square minus y is a x square y, this one, plus x square a square equation equal to, here it is b square y square minus y4. Okay, so it is minus y4 minus sine a square y square. This is plus sine y cube, y is a, y cube, y is a, y square into y cube. So first neglecting y4 and x and y cube. What are the tangents, smallest degree terms if I obtain? So the tangents possible. So the equation of tangents to obtain, this is the required equation here. Let me take this as third, fourth. Yeah, it is the fourth equation. So to obtain the equation of tangent from this equation, tangents, okay, equating the smallest degree terms, to 0. The smallest degree terms to 0. Okay, so here we x, this y cube, y4, neglecting them. What do we get? This is x square. Okay, let me take b square y square, x square a square. Okay, and a square y square. This is the equation here. What do we get? X square, because this is x cube, x square y cube, this is q degree. The fourth degree is only this term, and this one. The three terms are left over. This is x square, a square. If I take them to this side, it will be plus y square. If I take common, a square minus b square. This is a square. After taking this to this side, a square minus b square equal to 0. So this is the smallest degree term, which is square degree terms of the, from this equation we have equal to 0 to obtain the equation of tangents. So what do we get here? Now from this equation, if I take equation of the tangents, then we see here that y and the x, values of y and x, if a and b, let me take this here, okay, because this equation will be required again and again. Let me take this equation here. What do we get here? This one. So x square, a square plus y square into a square minus b square equals 0. What is it? If a is less than b, this value will be then negative. If a is less than b, this value will be negative then, because if a is less than b, or if I take b square minus a square, so this is b square minus a square. Okay, so that is b square minus a square, if I, or a square minus b square. There are different conditions here. Okay, so what are those different conditions? If first condition is, if a is from this less than b, first condition is a is greater than b. What is condition? A is less than b. Then if a is greater than b, first condition, let me check. It means this will be positive value. Then if a is greater than b, then y square into a square minus b square will be positive. Meaning positive value. from this equation, let me take fifth equation. What do we get? If A is greater than B, this we have taken, that means this value will be positive. From this, x and y will be negative, means value of x, then the tangents obtained, then the tangents obtained will not be real, the obtained will be non-real, imaginary. What is the problem with this? Let me check it. So these two are positive, then if I take y to that side, it will be negative. That in that situation, x will be negative value. X will be not plus minus, but plus minus with negative imaginary value. Y here, this is minus y, okay. Or if I take this minus sign here, this is minus y square, or y square is okay, but this will be iota into y into a square minus b square, or square root of this is half square root. Its value is imaginary value. The two tangents will be imaginary and distinct. It means non. Then this cusp a minus 0 minus a will be a conjugate point, and 0 minus a will be a conjugate point. Okay, the point. So this is giving us a conjugate point. Let me take that, then so that will be a conjugate point. Then 0 minus a, because no real terms or no real tangents are possible, that means it will represent a conjugate point. 0 minus a will be a conjugate point. Will be a conjugate point. Will be a conjugate point. Conjugate point. Only possible then is a conjugate point then. And second condition, if A is less than B, second condition, if A is less than B, then this term A less than B will be negative. Then x square A square, this one x square A square will be equal to, so this is negative positive value now. So this is b square minus, or if I take minus and common, because b is now greater, this value will be greater, that means minus sign, I have taken common, so it will be y square into b square minus a square. Okay, so this is positive now. Then x will be plus minus two positive value, y upon a, b square minus a square, square root upon a. Then the tangents will be real tangents. Okay, the tangents will be real and distinct. Then tangent will be real and distinct. Then tangents will be real and distinct. Or curves will be real, but tangents will be distinct tangents. So it will represent a node. Then 0 and minus a will represent a node, because when tangents are distinct, that will represent a node. It is a node, then second condition. So it is a node. Second condition, when a is less than b, then 0 minus a is a node, because then tangents are distinct. Third condition, which is not given there, but let me take that. Now if a equal to b, third condition, if a equal to b, in that situation this 0, x equal to 0 in that situation, x square equal to 0, or tangents will be coincident, and tangent will be x equal to 0, x equal to 0, equal to x equal to 0. So tangent will be then, or the tangent will be, so the tangent will be coincident. It will represent either a cusp or a conjugate point, but conjugate point will not be there. But it will represent a cusp then. So 0 minus a, then 0 minus a will be a cusp, or it will be a cusp of first kind or second kind. Okay, so then we have to solve the equation again in terms of y, with the values of y in terms of x, then positive, negative. Cusp will be of first kind, first species, second species. That can also be done easily. Okay, that can be determined from the equation given here. If we neglect yq xq from that equation which we just calculated. Okay, from that equation, if I eliminate y4 and x4, so y4 and yq, and taking y square comes from y square and y, or coequation in y, then y in terms of x can be calculated. From that value, if I find out that what is the quality of the cusp there, cusp can be, or first species or second species can be checked easily then. If that is the point there, we can check. But it will be a cusp, this is true. Second condition, when a is greater than, a is less than b, then it will be no. If a is greater than b, no imaginary tangents are there, so then it will be a conjugate point. So then 0 minus a will represent a conjugate point. So these are the cases, a greater than b, less than b, okay, or equal to b. That all the three conditions we have discussed about. These are the cases here. So the 11th question is finally solved. Now let me talk about 12th question. So what about 12th question? Let me check it. Question number 12 now. What is the question? What is the question here? Let me check. Okay, let me solve it. 12th question says, examine the nature of the origin on the curve dish. Now, origin, what is the origin here? Let me take it. So here curve, 12th question. Question number 12. The curve is, I'm sorry. The curve is, the curve here, this is AQ y square minus twice AB x square y, right, plus x5 plus c minus 4 x6 equal to 0. Okay, so if I find out the equation of the, okay, if I take it as quadratic equation in terms of y square and this term only, let me neglect this. Neglecting solution here. Neglecting, let me take x6 term, x term, and solving the given equation, the given equation of the curve in quadratic equation of y, in terms of quadratic equation of y. So this is quadratic equation of y. This is y square term, and this is x5 constant that we take. In terms of y, we have taken this as quadratic equation and neglected this term. What is the value of y? Y can be represented as here. Y from this will be, this is b minus twice ab x square is the b value. C is this, a is aq. Okay, so this is twice ab x square. So the minus sign is already there. We take minus b plus minus under root b square, that means 4a square b square x4 minus 4ac. Yeah. Minus 4 into a into c. That means 4 into aq into x5 divided by 2aq divided by 2aq, because this is the. Now if I take 4 common out of this, it will give us further 2 to then cancel out. It will be only abx square plus minus under root. It will be even 1a is also, 1a can also be taken out. Let me take a out. It will be a here out of these two. A square, if I take outside, so a will come out, and 4 is also gone. It will be only b square x4, right? B square x4, or even if I take x square common out of this, or x4 out of these two, from this x will be, okay, let me take x inside, no problem. Now this is b square x4, a and 4 cancel out, minus sign, this is aq, a only, but the one a square are taken outside, and this is x5 divided by 2aq, so 1a cancel out, this is a square only, and sorry, 2 is also cancelled out, 2 are taken outside, but 2 is also cancelled out. What is the finally value, which is b into x square plus minus under root, this is b square x4 minus a into x5 divided by a square. Okay. Now, what is the condition of for small values of x and y? Suppose the origin is the double point here. Say for the origin, they say examine the nature of the origin on the curve. This what is the origin on the curve? Origin is the double point, suppose. What is the nature of that? That we are finding out here. So in case of origin is the tangent, origin is the double point. In that situation, we are finding the tangent values. The value of y will be what kind of condition will be there? Let me now check this, if this value is it positive or negative for the smaller value of x.